Let's look at finding the derivatives of tangent and cotangent using the quotient rule. Recall, the quotient rule is, let's say I have two functions and they are being divided, right? We got something in the numerator, something in the denominator. I want to find the derivative. Well, then we have to do low d high minus high d low. There we go. All over low squared. Now you might be thinking, well, tangent isn't a quotient. But you have to remember that tangent can be written as sine over cosine. And if we know the derivatives of sine and cosine, well, then we can definitely use the quotient rule in order to figure this out. So that means the derivative of tangent is equal to low d high, derivative of sine is cosine, minus high, derivative of cosine is negative sine of x, all over low squared. Simplifying this, we got cosine squared, negative times a negative is a positive, sine squared, oh my gosh, it's the Pythagorean identity. I like to call it the mop squeezer. All over cosine squared. We know that the mop squeezer, or Pythagorean identity, is equal to 1. So that means the derivative of tangent is 1 over cosine, which is equal to secant squared. That's super neat. Right, one really important derivative that you have to know because you don't want to do this whole process every single time you want to figure out the derivative of tangent. Let's do cotangent next. So f of x equals cotangent of x. Cotangent is the reciprocal of tangent, so that's going to equal cosine over sine. Then the derivative, using the quotient rule. We got high cosine of x, d low, derivative of sine, low d high minus high d low. I'm doing this backwards. Low, sine squared, sine of x, d high, derivative of cosine is negative sine of x, minus high, d low, derivative of sine is cosine, all over low squared. Simplifying, we get negative sine squared x minus cosine squared x. Well, Marley. Anyway, sorry for my dog barking. Negative sine squared x minus cosine squared x divided by sine squared x. Now, it's not perfectly the Pythagorean identity, but what if we took out a negative 1? And there it is. Now we can substitute that out for 1, so we have negative 1 over sine squared, which is equal to negative cosecant squared x. All right, whenever I'm remembering these derivatives, I remember that all of the sine-related derivatives, so cosecant, anytime there's a cosecant, anytime there's a sine, you're going to have a negative with it.